Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. As usual, I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now, what is the major product of this reaction? This is actually bromobenzene and it reacts with this ditertiary chloride, okay, in presence of anhydrous AlCl3 as catalyst. Now from this reaction, what do you think? What kind of reaction it is? It is actually aromatic electrophilic substitution, and here anhydrous AlCl3 in catalytic amount, it acting as Lewis acid. So what can happen? Actually, we have studied previously that this bromobenzene is orthopara orienting but deactivating. How? So this one of the lone pair can go there and you can draw. By the way, student, I suggest everyone, please practice drawing resonance. It may look boring, but it is essential for learning. So this negative charge will come here. Another thing you may think, sir, another canonical form, it will go. So in this way you can draw another canonical from here. Obviously you can see here this carbon bromine has a double bond. So few canonical forms have double bond, few have single. So you can consider that this CBr bond is actually stronger. Why? Because of partial double bond character. Okay, so in this case, do not get confused, sir, why this carbon bromine bond will not break, why these will break? Answer is that this is stronger because of carbon bromine partial double bond. So that's why it will not break, whereas these will break. Now let's come to this. So from this resonance you can understand negative charge is here one time, another. So the two ortho and the para position are comparatively electron rich. So that's why it is orthopara orienting and it is deactivating. Why? Because the plus R effect is less efficient than the minus I, means sigma withdrawing, because this halogen is more electronegative atom, so its withdrawing effect, minus I effect through this carbon bromine sigma bond is stronger compared to its plus R effect. So consequently it is overall deactivating in nature. So if aromatic electrolytic substitution will take place, that will take place at either ortho or para position, but its activity will be lesser than simple benzene. This is the conclusion. Now let's go to the main mechanism. Actually this problem is based on the regioselectivity and obviously criteria for cyclization. I will listen the next step. So regioselectivity means position of reactivity, where the reaction will take place. From the previous discussion you can understand this bromobenzene can react with either ortho or para position for aromatic electrophilic substitution, but here in this case where the reaction will take place, that question could be answered from one basic understanding. As I told, the minus I effect is dominant over plus R effect, and minus I effect works through sigma bond. Now if you say the two ortho position that is pretty closer or directly attached with this carbon which is facing the minus I because of this bromine, so can I say this position is comparatively lesser electron rich than para position? I repeat my statement, student. I am saying that this position is comparatively lesser electron rich than para. Because of resonance, both ortho and para have some extra electron density, but para has more electron density than ortho because of stronger minus I effect. Now if you do the aromatic electrophilic substitution, preference for AES is at para position. So after the first alkylation in presence of the anhydrous AlCl as catalyst, product will be this one. See, it is alkylation, so this is Friedel-Crafts alkylation. Okay, now student, I am not showing the mechanism in details. I request, if you have any doubt and you want to learn more the mechanism, I suggest you please visit the links I shall provide in the I button or description box, where I have already described a dedicated lecture regarding this mechanism. You may visit for further learning. So let's come here. So here this Cl will be replaced and this hydrogen will come from here and it will come as HCl. Remaining, this carbon center will be attached to this carbon center. Now this carbon center is attached to two methyl group, student. Very careful while writing such kind of structure. So one methyl group, another methyl group. Now after that there are two CH2. So 1, 2. Now again another tertiary carbon. I mean one methyl group and one chlorine. So this is the product. Now student, you may think, sir, why have you drawn in this way closer? You can draw it in a different way also, because CC rotation allowed, I agree, but I have an intention, I have a purpose. Now what is the purpose? Since when a CC bond is formed here, some other kind of reaction can take place later on. See, again anhydrous AlCl3 present in the reaction medium. So further alkylation possible, this CCl and any one of these meta proton. Now you may ask one question, that sir, sometime before you have said that bromobenzene is orthopara orienting. Since the para position is blocked or substituted, then reaction can take place at the ortho position. Why you are talking meta? Depending on the ring size, student. If you count from here, means this is 1, I mean the bond formation will be carbon-carbon bond. So 1, 2, 3, 4, 5, 6, 7. Now 7-member ring formation with such kind of orientation is not possible. It will have a severe ring strain compared to if you connect this 6 and 1, these two. So here it will be a 6-member ring strain will be less. Now that's the reason it will react. So ring formation means again H and Cl will come out. So second step also byproduct is HCl. Here this is Br. In para position draw a 6-member ring. This 6-member ring is student new one. Now this 6-member ring is attached with here 2-methyl, here 2-methyl. So this is the product. Okay, now let's go to the question. So which one is the product? Obviously para position and meta, para meta. So with respect to this is para and meta. So C is the answer. By the way, student, if you feel, sir, I'm confused, how can I get the right answer less than 30 seconds? Use your common sense. Anhydrous AlCl3, carbon chlorine bond and bromobenzene aromatic nucleus. So Friedel-Crafts reaction, carbon number should be added. Either cyclization take place or not, doesn't matter, but carbon number should be add up in the final product. But look at here, in this case, one methyl here, another methyl here. What is the fate of the remaining 2 methyls? CC bond breaking is not that much easy, students, so it's a wrong option. If you look at anhydrous AlCl3, this reaction, what about the bromine? Where it gone? Wrong option. So if you are little conscious, you can eliminate these processes. Okay, this is called process of elimination, very helpful while solving MCQs. Now this part we have understood. Now confusion is option A versus option C. How can I get the option A if the reaction starts from here? Now later on it can cyclize this way, but I have explained just some time before that this ortho position is comparatively lesser electron rich than para. So reaction will be, means the first Friedel-Crafts reaction will start from para position. So obviously option A is gone. Which one is remaining? Option C. That's the right answer. Now you have to think this quickly, and for that purpose more study and more practice is enough. So this is the overall discussion. I believe this video will be useful. Thanks for watching. See you in my next video. Bye bye.